Okay, the other format of parabolas, kind of the multiplied out version, ax squared plus bx plus c. Now, here's how I'm going to do it, but there are some teachers, so if you have, your algebraic past in high school, there are some teachers that would tell you to take this version and complete the square on it. And then once you did that, you could do it the same way we did this problem. And that works perfectly well, and if you like that, that's fine. I've just found that telling people to complete the square on this, they have a tendency to make a lot of mistakes in completing the square, so then the rest of this turns out to be wrong. But if you remember how to complete the square and want to do it that way, that is perfectly fine. What we're going to do instead, or what I prefer, is I prefer to learn this little fact here, that if I have ax squared plus bx plus c, so it's kind of all multiplied out, the vertex is the point, negative b over 2a, f of negative b over 2a, where the a and b, same a and b as in the quadratic formula. That is, the x-coordinate is found by using this tiny little formula, x equal negative b over 2a, and the y-coordinate is f of negative b over 2a, or that is, to find the y-coordinate, take the value you found for the x-coordinate and plug it into the function. And then everything else is exactly the same as before. The only difference when it's in this format is how I'm going to find the vertex. Everything else is exactly the same. So, doing another problem here again. Use the vertex and x-intercepts to sketch the graph of the quadratic function. Give the equation of the parabola's axis of symmetry. Use the graph to determine the function's range and domain. So same instructions as before, just slightly different. So for the vertex, x is going to be negative b over 2a. So in this case, negative 1 over 2 times 1, or negative 1. Then my y-coordinate is going to be f of negative 1. That I take whatever I got from x and I plug it into the function. And so I get negative 1 squared plus 2 times negative 1 minus 3. And I work that out. Now some of you do everything on your calculator, which while I don't particularly like that, I don't have a huge problem with it. It's a fact of life that a lot of students do all their arithmetic on their calculator. If you do this on calculator, that is how you have to type in the calculator to get it to square the number negative 1. If you do not use parentheses when you put that in on your calculator, it will do it wrong. Whenever you're using your calculator to raise a number to an exponent, a negative number to an exponent, you've got to put that negative number in parentheses. Otherwise, it's not going to give you the result you anticipated. Calculator is going to do it correctly. It's just not what you anticipated. So doing that, that's going to give us 1 minus 2 minus 3 for negative 4. And so my vertex is negative 1, negative 4. Y-intercept, and like I said, everything else is exactly the same. Plug in x equals 0. So y equals f of 0, 0 squared plus 2 times 0 minus 3 for negative 3. I'm just going to go ahead and go on another piece of paper because I'm running out of room already. X-intercepts always set equal to 0. So x squared plus 2x minus 3 equals 0. And then solve that in your favorite manner. Since it's all multiplied out like that, best bet is either going to be the quadratic formula or factoring, whichever seems to work for you. This guy factors pretty easily to x plus 3, x minus 1. Remember, the first terms have to multiply to be the first term, so x times x, x squared. The last terms have to multiply to be the last number, negative 3. So 3 times negative 1, negative 3. And then checking the factoring, if I look at the outside and inside, on the outside, I get negative x. On the inside, negative or positive 3x. And so 3x minus x, 2x. And so I'm just checking the factoring there. You don't have to do that, but that's just me reminding you about factoring. That doesn't even look like checking factoring. Check. We'll write it down beneath it. Check factoring. And that is certainly an optional step, but just reminding how we're going to factor these guys. First terms multiplied by first term, so only choice I have for x squared is x and x. Last terms multiplied by last term, 3 times -1, -3. And then I do the outside and inside just like FOIL to check that middle, and it works out. Because it's factored and equal to 0, I can split this up. And so I get -3 and 1. There are my x-intercepts. My axis of symmetry. Always the x equals the x-coordinate of the vertex. So in this case, x equal -1. And so now we're ready to graph. And we had f of x equals x squared plus 2x minus 3, or very specifically 1x squared plus 2x minus 3. So my a value is 1, that is greater than 0, so it opens up. And we know that the vertex was -1, 4. -1, -4, went the wrong way. 1, 2, 3, 4. So we know vertex was -1, -4. So right about there. We know that the y-intercept was -3, so right there. And then we knew the x-intercepts. -3 and 1, so there's -1, -2, -3, and 1. And then you just do your best to draw a parabola through them. And there's a good enough parabola. Then lastly, the domain and range. As we've said every single time, the domain is -infinity to infinity on all of these things. Range, lowest y to highest y. Well, my lowest y happens to be that vertex, -4 to infinity. And then you could check it by looking at a picture. And let's go ahead and check this. This one's going to check pretty easily. Y equals, clear out the old thing, and it was x squared plus 2x minus 3. And we'll just do the standard window, zoom 6. There comes a parabola. It looks pretty much the same as what we had, but then we can check everything. We said one of the x-intercepts was -3, so let's do a trace. Put in -3. Yep, there's an x-intercept. Zoom in a little bit. We said the other x-intercept was 1, so just enter 1. And it goes to the other x-intercept. We said the vertex was -1, -4, so let's put in -1. See down below, we see the -1. Enter. And it does indeed go to the vertex, -1, -4. And then we said the y-intercept was -3, so let's put in 0, because remember the x-coordinate has to be 0. I put in 0. And there it is. And so it all absolutely checks. You got a few minutes at the end of a test. Check these things. They all check. Okay, so there's that one. Going back out. Last of this type of problem. And then we'll move on topics just a little bit. Still more parabolas, but a little bit. Same instructions, so really kind of the same idea. Let's do the problem again. The vertex. When it's written like this, for the x coordinate, we use the tiny little formula, negative b over 2a. And you just need to memorize that. And so this is going to be negative 2 over 2 times negative 2, negative 2 over negative 4 for 1/2. That makes my y coordinate f of 1/2. And so negative 2 times 1/2 squared plus 2 times 1/2 minus 1. And yeah, sometimes you're going to have nasty little fractions, and you just have to deal with that. So it's going to be negative 2 times 1/4 plus 1. Negative 2 times 1/2 is 1. Minus 1. So the 1 minus 1 is going to go to 0. So I have negative 2 times 1/4. Just being very specific with all my arithmetic. Negative 2 times 1/4, which is negative 1/2. And so my vertex is 1/2, negative 1/2. Not pretty, but that happens. Then doing all the other stuff. Y-intercept. Every single time you plug in x equal 0. So y equal f is 0. So negative 2 times 0 squared plus 2 times 0 minus 1 for negative 1. X-intercepts always set equal to 0. So negative 2x squared plus 2x minus 1 equals 0. And you can stare at that for a really long time. It's never going to factor. So we're going to use the quadratic formula. One thing I'm going to do just to make life a little easier, I'm going to divide all terms by negative 1. Just because that way I don't have that negative out in front that I have to deal with. So that's giving me 2x squared minus 2x plus 1 equals 0. So a is 2, b is negative 2, c is 1. Write a little bit smaller here. So I'll go up here and finish it. X equals negative b plus or minus b squared minus 4ac all over 2a. And so I've got negative 2 plus or minus negative 2 squared minus 4 times 2 times 1 all over 2 times 2. And again, a comment that if you're going to use your calculator to help you with this arithmetic, and in my formula where I have a b squared, so I'm going to square the number negative 2. If you're going to use your calculator, that negative 2 has to be in parentheses. Absolutely has to be. One of the most common mistakes, people will use their calculator to do this arithmetic and they don't put it in parentheses, which screws everything up. On the next video, we will finish this problem.